Hey guys, how's it going? Welcome back. So today we're going to talk to you about RC helicopter antenna mods. This is more or less just on your 3-channel stuff or megahertz band stuff. Now the Litehawk areo is one of the ones in question here as far as ways to improve the range. Now a lot of guys have tried, and including myself, unwinding the antenna, stretching it around the boom supports, that sort of thing. Now I found that it actually caused more interference problems and lack of range than it actually did any good. So it did no good. Leaving it completely stock, it's fine. It does have its limitations. They rate them for somewhere around 70 feet from Litehawk, and 70 feet really isn't much considering how much you're paying for these things. So we need to improve range. Now one of the ways you can improve your range is, of course, by lengthening your antenna on your transmitter. Can improve range somewhat. Some guys have actually had to do it just to get any real range at all out of their helicopter. So anyway, the alternative is, instead of having a 6-foot or 10-foot long antenna coming off your remote, which is absolutely ridiculous, very unbalanced, and a real pain in the neck, is to lengthen your antenna. Well, you don't necessarily have to lengthen your antenna. In fact, you can get away with going with a shorter antenna and increasing range. So let's talk about that. Now this is a wire that you'll commonly find on the Litehawk arrows, antenna wire. Okay, now what I've done is I've stripped the end casings and I've separated the wires. And doing a wire count, you've got 1, 2, 3, 4, 5, 6, 7 wires inside here. Now this is just some general purpose voltage and or speaker wire for using up to about 12 volts worth of power. Okay, a little thicker stuff. So I've taken a piece of this, and of course I've also separated it. And one thing you notice right away is that it's copper, and this is more like a steel wire or some sort of a tinny wire. It's just not a very good wire overall. Copper is a better conductor and a better attractor when it comes to antennas, in my opinion. Okay, especially when you're finding a copper always around your house, electrical wall sockets and speaker wires, etc. Copper does make the best conductor, okay, especially when it comes to heat too. So anyways, we've taken some of this wire apart, and doing a count on it, we've come up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 strands. Okay, so the next thing we want to do is we want to check the thickness of these strands. So you're going to need a digital caliper, and you're going to take one of the strands out, stretch it out straight, make sure your caliper is set to 0, and we're at 0.004.5 for the wire thickness on this wire. So let's check our copper wire out. Again, make sure it's zeroed out. And we're at 0.006. So we're a little thicker. So what's this mean? Well, even if it was the same amount of strands, the copper alone is going to be a much better conductor, so you could actually get away with a shorter antenna at the same amount of strands in the copper. Being that this is slightly thicker, also is going to allow you that shorter wire. So if you're after a shorter wire and still longer range, you need more strands, slightly thicker wire, and go copper. Okay, and that's the trick. So you want to measure the exact length of your antenna wire. So you're going to have to desolder it from the circuit board here, and then take it all out of the tube, measure the exact length. Okay, and of course we already know there's 7 strands in there. And then we're going to take the same stuff in this speaker wire, which is thicker, and it's got a few strands shy of being 14, so double. Okay, so it's 11 strands, and it's thicker. So at 11 strands, slightly thicker, we're looking at almost 20 strands worth by the time you're done the math. Okay, and that's going across, you measure it the same length, that's going to give you a lot of increased range just being at the same length. Even if we cut it in half, for half the amount, we're still increasing range because we're already more strands and we're thicker wire. So let's chop that length back again and half again. Okay, so it depends on where your goal is. Now my goal with this, where I would suggest, would be to go with the shortest wire possible and still increasing range, right? So that to me would be the practical thing, because you don't want to have this stuff tied up on your landing gear either. I mean, the landing gear is very flexible, it's going to take a lot of hits. Now in colder weather, of course, the plastic landing gear is going to become a lot more brittle, so it can break easier. So if you snap your landing gear off, you can actually do some damage here and rip the connector wire clean off if you get a break on this ski and have a bad crash. That could happen, okay, in which case you could damage your PCB board, which is actually your speed control and everything all in one, receiver all in one. So it's your receiver and DCS in one. So you don't want to be doing damage to that, so you want to get that out of the way. So I would suggest going with the shorter wire, thicker strands, and having more strands and still increasing your range. So the modification that we're going to end up doing on this one here is just that. We're going to go with a shorter wire. Now I already know right now the kind of range I'm getting. I'm getting an easy 200 feet out of this thing, which is actually a little overrated from what Litehawk specifies. But this has also had a little tiny bit of frequency tweaking too, to get it more super dead on to match the transmitter. Because it was a little bit out, I found, originally with this black model. Now I also had the white model, which is actually up for sale on my website. And it has a new PCB board in it, as well as a new remote. So, but this one here is completely stock. I've not changed anything on this one yet, and that's what we're going to do. We're actually going to change things. So let's take a look, and instead of getting exact measurements here, I'm going to just take this wire and stretch it out. And then I'm going to do the same. I'm going to take it up onto this one. And we're going to hold her even. Right to there. And clip. Now that we've got the same length, we definitely know with the same length and almost twice as many wires, our actual length in reality, if it was the exact same thickness of wires, same amount of wires, we're going to be looking at a full length plus just shy of 2. We're going to be just shy of 2 easy. Okay, so I don't need all this ridiculous length of wire, do I? No, it's way too much wire length. So what I want to do is I'm going to say, okay, this looks to be, let's say this is about 20 inches. Alright? Now at 20 inches at almost double, that's 20 inches, slightly thinner, not by too much. I can actually get away with definitely cutting this in half for sure. There's my half mark. So now I'm down to about 10 inches of wire. Okay? Still having thicker and more strands. I'm technically still longer than this big long sucker. And I'm half the length. Okay? So because of that, I know, again, I can cut this pretty much in half again. So now, taking into consideration I have 11 wires in this short piece, I have 7 wires in this piece. The wires in this original antenna are very, very tiny. These are slightly bigger. I'm 1/4 the length, okay, basically, or 1/3 the length. This length here is still going to be, in overall thickness and frequency modulations and everything else, it's going to be an easy equivalent to this thing, but it's also going to be better. And it's going to help increase range a little bit more, because why? Because instead of having steel or tinny wires, we've got copper wire now. Okay, copper, much better collector, much better control over voltages. Okay, so, and it's going to respond to the frequencies a little bit cleaner too. The thicker the wire you go on speakers, for instance, the thicker the wire, the cleaner things can get, even at higher volumes, because you're now allowing those speakers to draw more through that thicker cable. Okay, that's why they had monster cables and high power stereos, etc. You had to have those, because if you use skinny wires, you could actually light them up. They'd burn out, and they could actually catch fire if they got too much going through them. And it causes a bottlenecking effect too, which can also damage your equipment. So, in the case of this, we have thicker wire. It's now very much shorter. Okay, it's not going to be in the way of anything. In fact, we can hide this little piece of wire right inside the canopy and not have anything. Okay, and so that's going to be our goal. So what we're going to do is, first thing, we're going to take a nice picture of the layout of our wires, because we're going to want that. Because then you got to remember where everything plugs in, because we got to take this PCB board off and we got to flip it upside down. Okay, so I'm going to grab my smartphone here. And voila, I've got my picture. Now I have a reference point to go back to. So I'm going to unplug all this stuff, come back and have the board flipped upside down, and then we'll go to the next stage. Okay guys, we got our PCB board out and hanging, and we decided we're going to go with the longer wire out of all of them. This was the short one that would do the trick plus give some extra range. So we're going to go with the actual longer one. Alright, this is going to give us, you know, maximizing out the range and still keeping things nice and compact and be able to bury it in the hood. So what I've done on the other end of the antenna is I've put on some heat shrink tubing to close off the end. Okay, and it's actually about roughly ½ an inch, 3/4 of an inch past the end of the wire, and it closes itself off really nice. Okay, this way it's going to ensure that no matter what happens, there's no way it can short up against anything. So we stripped a bit of the casing off, and we're going to tin the wire, so that we're going to do that now. And we really don't need very much on the tip of this wire at all. So we're going to trim a little bit off there. Now, we got to remove the old wire. Now, I know it's going to be hard to see this, but find out where your wire is soldered onto your board, and you're going to remove it from that spot. That simple. Okay. Now, this is where our helping hands is going to come in handy. There, that'll hold that nice and solid so that we can put our new antenna wire in place. Okay, right there. And that's it. New wire's in place. down with the soldering iron. So now it's time to put this back together. So we'll be back in a minute and we'll have this reassembled. Okay guys, so we've got everything reassembled again. So the next thing we want to do is test this thing out and make sure it fires up. Okay, so fires up, that's awesome. Turn the power off, and I'm going to put our canopy back on, and I'm going to just feed the wire on the inside of the canopy. Because the wire doesn't need to hang out. I actually have a couple of 3-channel helis where the wire is actually inside the canopy, and it's actually much better inside because it's out of the way of everything. Okay, so canopy's back on. Let's give this another go. Turn on the transmitter. Helicopter. Grab the camera here. Okay, so we definitely got power. A little too windy today to fly this. So what we're going to do is we're going to give it a couple days, see what tomorrow's like and the next day, and because the arrows do not like high winds, and it's pretty windy out there, so I really don't want to lose this to the trees or smash it up. So we're going to see what the weather's like tomorrow, and if the weather's good tomorrow for flying with this thing, then we'll give it a flight test. We'll see how the range does, see how performance is as far as response to controls. We already know close range for sure, throttle response is definitely on, so will our other controls, but the big test is going to be for our distance and see how she does. So we'll have to come back with a flight video of the antenna mod on this black Litehawk arrow to show you guys how well it did. But that's how you do the mod. That's some rough estimates on the math and the thicknesses, you know, that you're going to be dealing with, and to be aware of when you're going to do this mod. And you know, if you do go for an even longer wire inside, you could go twice the length I did, and it would certainly help. But you might want to at that point put it on the outside of the skids, you know, or leave it in the canopy even. Like I said, I've got helicopters with, you know, they've got 18-20 inches of wire that's all bunched up and just into the canopy with a zippy tie right from the factory, and I get 300 feet out of those things. Anyways, that's it. Thanks for watching, and we'll see you on the next video.